Okay, good morning. Welcome to
KidMath100.
KidMath100. So today we were in what section is this? 16.3 of Art of Problem Solving's algebra book, and we were talking about composition of functions. So we did their first example, which was this f of x equals 2x minus 6, g of x equals 3x minus 9, and what is f of g of x? And how did we answer that question?
Well, g of x equals 3x minus 9.
Okay, so this was the same as f of 3x minus 9.
And so you have to multiply this by 2 and subtract 6.
Okay, so whatever goes into the function,
It's multiplied by 2.
that is multiplied by 2, and then you subtract 6. So this is 2 times 3x minus 9.
Which is 6x.
Minus 6. Well, let's not jump ahead. Okay, f of 3x minus 9 is 2 times 3x minus 9 minus 6, because that's what this tells us to do here. Whatever goes in, multiply it by 2, subtract 6.
Yep.
Now you can simplify.
It's 6x minus 18.
6x minus 18
minus 6.
minus 6.
Which is 6x minus 24.
6x minus 24. Okay, but so that's fine, and this is important to understand and make sure we know how to do. But I wanted to show you a couple of other examples of combining functions.
Yep.
Okay, and the first one's going to be on a Rubik's cube. We're going to call f of cube equals move the right face up.
Like this.
Okay, and we're going to call g of cube move the top face. Which way do you want to move it?
Clockwise.
Clockwise, okay. Okay, so right's over here. Hopefully this is right on camera. So f moves the right face up.
Yep.
And g moves
The top face.
top face clockwise, like that, right?
Yeah.
Okay, so in cube language, this is an R move?
Yep, that's an R.
And this is a U?
Yeah.
Okay, awesome. Okay, so if we do f of g of cube, we get, okay, well, let's see. Well, f of g of cube. What's g of cube?
G is move the top face. Like
Top
that.
face. And then f of that is that, okay? So you can see we get this, the way we started, you get this yellow pattern on the top and red and green, right? Okay, now let's go back. Let's do g of f of cube. And let's see what we get. Okay, what's f of cube? And what's g of cube? Is that the same thing?
Nope.
No. So that's pretty interesting. Pretty interesting. We're starting to see composition of functions is not commutative. F of g of cube is not the same thing as g of f of cube. So it's pretty neat, and it's an interesting thing to see on a Rubik's cube. So f of cube up and then g over.
Not the same.
Not the same as over then up. Right? Get this little green square on top, for example.
Yeah.
Okay. The other thing we looked at for composition of functions today was something called the Mandelbrot set. And we actually got some code and on Mathematica and made it. I'm not going to show that right now. But with the Mandelbrot set, what you're doing is you take f of some z, and then you take f of z, and then you take f of z, and you just keep doing this iterative process where you keep applying the function to the output of the previous one. F of z, start at z, go to f of z, go to f of z, go to f of z, and you iterate through and you get this amazing picture called the Mandelbrot set. I'm skipping some details,
Yeah.
obviously. But the Mandelbrot set is about iterating functions, and it's about f of things.
Yep.
Okay. So composition of functions has some really interesting applications. Really interesting stuff. All right.
All right.
Good job, hon. Good job. It's a neat, very neat topic, composition of functions.